Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. Fx is equal to ax square plus bx plus c, where a, b, and c are real numbers. If fx is an integer whenever x is an integer, which of the following statements must be true? And we are given 4 statements. Statement number 1 basically states that a plus b and c must both be integers. Statement number 2 is both of a and b plus c must be integers. Statement number 3 stating 2a and c must both be integers, and statement number 4 stating that a plus c and 2b must both be integers. And then we are given 5 options, and these basically involve point to only one of those statements, or a combination of 2 of those statements above, and we have to basically pick which one of the options from A through E is correct. So how do we solve this problem? The solution to this problem is actually pretty simple if you really follow the correct sequence of steps. And simply, it's given that fx is a quadratic function of x, and it takes the form ax squared plus bx plus c. And further, whenever x is an integer, fx is also an integer. So let's apply this criteria to f0, because that's the simplest thing that we can try. And for f0, we basically, put x equal to 0 on the right hand side of ax squared plus bx plus c. So x becomes 0 there. So we have a multiplied by 0 plus b multiplied by 0 plus c, and that becomes equal to c. Now, this implies that because f0 is an integer, c must be an integer as well. What about f1? f1, again, we substitute x equal to 1. We get a1 squared plus b multiplied by 1 plus c, and that's simply a plus b plus c. Now, we know that f1 has to be an integer because 1 is an integer. So whenever x is an integer, fx has to be an integer. So 1 being an integer, f1 has to be an integer. So a plus b plus c has to be an integer. But c, as we have shown in the previous step, is an integer. It must be an integer, right? So if f1 equal to a plus b plus c has to be an integer, and we already know that c is an integer, then a plus b, that's the term that I've underlined, that has to be an integer as well. So a plus b must be an integer. So far, we have seen that c must be an integer, a plus b must be an integer. So statement number 1 seems to be a correct option. However, going through the options from A through E, we don't necessarily know whether it's the only correct statement, because there are options, like for example, option B and option C, which basically calls out statement 1 in combination with either statement 2 or with statement 3 as a potentially correct choice. So we have to either prove that 2 or 3 or one of those are correct, or they're incorrect, in order to rule those options out. So the problem doesn't really end here, though it might seem to, because we have already got a good solid evidence that statement number 1 is correct, and option A does state that the statement 1 only is correct. So that could be a viable option here. but we have to still confirm whether the rest of the statements, especially those that include statement 1, are incorrect. So the process is very simple. So next we try x equal to 2. So f2 becomes a multiplied by 2 square plus b multiplied by 2 plus c, and this comes to 4a plus 2b plus c. And this has to be an integer as well, because 2 is an integer. So f2 must be an integer. So 4a plus 2b plus c has to be an integer. Now, this one, we can write 4a as 2a plus 2a. So we can write this expression as 2a plus 2a plus 2b plus c. And then from the middle two terms, we can take 2 common. So this expression becomes 2a plus 2 multiplied by, within parentheses, a plus b plus c. Now we know that c has to be an integer. So we just showed that in the previous step. We also showed that a plus b has to be an integer. And that means that for this whole expression to be an integer, the term 2a, that has to be an integer as well, because we know that a plus b is an integer. So 2 multiplied by a plus b, so that has to be an integer. C is also an integer. So that leaves 2a no other option but to be an integer if the whole expression has to be an integer, right? So the conclusion from this is 2a must be an integer as well. So now we can basically examine the statements, and we are finding that statement number 1 and 3 are correct. And at this point, it's safe for us to conclude that the correct option will be option C, statements 1 and 3 must be true.